Hello students, this video is to help review the Unit 3 lessons from Lesson 4 to Lesson 6. We talked about perpendicular bisectors, we talked about constructions, different pairs of angles in different intersections, and the relationships that they have. If you haven't already done so, please pause the video, try the questions from Lesson 4, and then come back to see if you get them right. Alright, all of these questions dealt with proofs. This one was no exception. A proof, remember, is asking you to write a T-chart with statements and reasons, and generally we start with the stuff that's given to us and we end with the statement that it asks us to prove. Alright, in this question, you could have used angles 1 and 3 are supplementary. You could have used the relationship of consecutive interior angles. It asks us to prove this using another method though, so we're going to use a different method. First, we start off with M and N are parallel because it tells us that whenever you see something that says given, that's something that they told us, either in words or in markings on the diagram, which we'll see a little bit later. Angles 1 and 2 are congruent because of alternate interior angles. We know angles 1 and 2 are alternate interior angles. That's that Z theorem. It forms a little Z here. We also know that angles 2 and 3 are supplementary because of something called linear pairs. You know that if two angles next to each other form a straight line, it's like this and like this, angles 2 and 3 form that straight line so that they are a linear pair. That means they're supplementary. They add up to 180 degrees. And then we said that angles 1 and 3 are supplementary because of substitution. We took out angle 2, and we replaced it with angle 1. In question number 2, it asks us to prove that the two lines are parallel. This is a common student error. If it says prove that the two lines are parallel, you can't start in with using something like alternate interior angles. You can't use corresponding. You can't use consecutive. You can't use any of those at the beginning of the problem because you don't know whether they're parallel or not. So there must be something else in the problem that lets you do it. The first thing I did here was number all the angles because there were no points here, so I wasn't able to name the angles with points, so I had to name them with numbers. So angle 4 is equal to 42 degrees. Angle 7 is equal to 138 degrees. We know that because they're both given to us. In this case, it wasn't given to us in words, it was given to us in the diagram, but it's still given to us. In statement number 3, we have angle 3 is equal to 138 degrees. I know that 3 is equal to 138 degrees because linear pairs are supplementary. I know that this line and this line create angles 3 and 4 are linear pairs. I don't have to show a whole lot of work for that. I could show that 180 minus 138 is equal to 42 or something like that, but not super necessary when you're writing a proof. The next statement I have is that angle 3 is equal to angle 7. I know that they're both equal to 138 degrees, so that they're equal to each other. The last step is to say that line M is parallel to line N. I know that they're parallel because of corresponding angles. So this is a sort of a backwards way of using the corresponding angles theorem. As long as these two angles, I think it was this angle here, and then this angle here, as long as those two angles are congruent to each other, that means that they are corresponding angles. That means that these two lines are parallel. For question number 3, it asks us to prove again that the two lines are parallel. So notice we didn't use any of those relationships until the very end. We didn't use alternate interior. We didn't use corresponding. We didn't use consecutive until the very end because we can't say any of those things until we prove that they're parallel. Notice that angles 1 and 3 are congruent and angles 2 and 4 are congruent because that's given to us. It tells us in the problem. And I know that ABC, this angle ABC, this red angle is equal to angle 1 plus angle 2. That's the angle addition postulate. I used the same angle addition postulate for angle BCD. And then what I did was substituted. Angle 1 is the same as angle 3, so I replaced angle 1 with angle 3 in this equation, and then I did the same thing. Angles 2 and 4 are the same, so angle 4 gets replaced with angle 2. Now I know that ABC and BCD are both equal to angle 1 plus angle 2. I put them together. Now you could call this substitution. We call this transitive property. The transitive property is a special property that allows us to take two equations and set them equal to each other. That allows us, we're allowed to do that because both of these equations, ABC equals angle 1 plus angle 2, and BCD equals angle 1 plus angle 2. They're both equal to the same thing. So if these two equations are both equal to the same thing, then the first part of the equations are equal to each other. That's called the transitive property. If you put substitution property, depending on the person who's grading your paper on the geometry regions, they would probably give it to you. And then parallel lines because of alternate interior angles. I know that this angle and this angle are alternate interior angles. They are equal to each other, so they're parallel. Moving on to the next page of lesson 4, pause the video, try it out, and see if you get it right. All right, this question asks us to prove that z is equal to x plus y. I was able to draw an auxiliary line here because of the postulate that we learned all the way back in lesson, I believe it was lesson 3. That parallel line postulate allows us to do that. Once we draw this parallel line to line AB and line CD, I'm able to split this angle into part A and part B. And I know that z, the whole angle, is equal to A plus B. That's basically why I drew the auxiliary line in the first place. Then I was able to say that angle X is equal to angle A because they're corresponding. They're both on the same area of that intersection. And then B and Y are the same because they're in the same area of those two intersections. Once I know that, then I can use substitution. Angle Z is equal to angle X, which is the same as angle A, plus angle Y, which is the same as angle B. I just did substitution. Notice I didn't do transitive property because I didn't take an entire equation and substitute it. I took part of the equation, which was angle A, and I replaced it with angle X. I took another part of the equation, which was angle B, and replaced it with angle Y. All right, question number 5, it asks us to prove this crazy statement, and there's a lot going on here, but I see an equals 180, so that means one of my relationships that I'm going to write down is going to have an equals 180 in it. So my first statement is that all these lines are parallel to each other. Notice that it didn't say that in words up here, but it did give it to us in the form of a picture. This symbol means parallel, and since they all have that symbol, they are all parallel to each other. I can say that that's given to us because it's in the diagram. Angle C plus angle D is equal to 180 because of consecutive interior angles. That's this angle and this angle. They're equal to each other. I'm sorry, they are supplementary because of consecutive interior angles. Now that I know that, I can say that angle A is equal to angle B plus angle C. Angle A is up here. Angles B and C are down here. And I know that this angle and this big angle are equal to each other because of alternate interior angles. Once I know that, I can do a little algebraic manipulation. I'm going to subtract B from both sides, and I get minus B on the left-hand side, and C is all alone on this side. Why did I do that? Because remember in my original equation, I wrote angle C plus angle D is equal to 180. If I substitute this part into this equation, I get angle A minus angle B plus angle D equals 180. That's exactly the same as this equation with a little rearrangement going on in here, right? Negative B, positive D, positive D. So I've proved it because this statement that it says in the prove is my last statement. For question number 6, it did require you draw an auxiliary line. This is an advanced style of auxiliary lines that you might not see on the Regents exam, but we include it because of completion. This line makes ABC into a triangle, which means angles D, E, and F are equal to 180, and angles A plus E and F plus C and B equal 180 as well. Once we write those two equations, we can say that D, E, and F is equal to B, A, E, C, and F because of that transitive property. These both equations are equal to 180, so we just took the left-hand side of both of those equations and set them equal to each other. Once we did that, we were able to subtract out E and F because they're the same on both sides, and lo and behold, we got the equation that it asked us to prove. No big deal. So those are proofs. For lesson number 5, it was asking about perpendicular bisectors and writing the equations. This was a skill that you definitely need to learn. It's something that will show up over and over again. Pause the video, try this out, and see if you get it right. All right, we did go over some of these in class. I did it graphically here just to show you how it looks, and then I did it using algebra here. The first thing we did was we found the slope, then we used negative reciprocal slope to find the opposite slope to that. The first part was finding the slope of the original line segment. The next part is finding the slope of the line that is perpendicular to that line segment. Negative reciprocal slope is needed because we're looking for a perpendicular bisector. If we were looking for something that was parallel, we would not need to do this, but since it says perpendicular, we must change it. Then we found the midpoint. Midpoint formula is something that you just need to remember. And it's a very simple process of adding the two x's dividing by 2, adding the two y's dividing by 2. We're doing the same thing over and over again. Then finding the y-intercept, recognize we're plugging in or substituting, I should say, the slope from our calculation of negative reciprocal slope, and we're substituting in the y value and the x value from the midpoints. Why are we using midpoints? Because it says bisector. We eventually get b is equal to 9. Once we get the y-intercept and the slope. Here's my slope, here's my y-intercept, turned into an equation very easily by substituting those slope and y-intercept into the equation. Question number 2, no surprise here, asks us to do the same exact thing. It doesn't give us the points, but we're easily able to find the points just by observation of the graph. This is -2, 4. This is 2, -4. So I found my slope using the same method, and I use negative reciprocal slope because it asks for something that's perpendicular. As soon as I see perpendicular, I write NRS, which means negative reciprocal slope. As soon as I see bisector, I write midpoint, and then I find a midpoint. 0, 0, and you could have guessed that by looking at the graph. This point is directly in between -2, 4 and 2, -4. The y-intercept is found in the same way. We substitute in the midpoint as the x and the y, and the negative reciprocal slope as the slope, as m, and we solve for, and then we substitute that into the equation y equals mx plus b. Notice here I was able to simplify. I'm not going to put this plus 0 because, well, that seems a little silly, doesn't it? If I'm adding 0, it's just that same exact thing. So 1/2 x plus 0 is the same as just 1/2 x. Writing the equation, y equals mx plus b. Perpendicular, negative reciprocal slope. Bisector, midpoint. Points, use the formula. This should be, by now, this should be a procedure that you know how to do. Hopefully you're able to follow this math. It's the same exact math from the previous problems. Moving on to side number 2 of lesson 5. Pause the video, try these out, and see if you get it right. All right, make sure every time you do a question like this, you're annotating it, because sometimes it might not say bisector, sometimes it might not say perpendicular, but every time it says perpendicular, you do a negative reciprocal slope. Every time it says bisector, you're doing a midpoint. Every time it's looking for an equation of a line, you're doing y equals mx plus b, and most of the time they'll give you the x1, y1, x2, y2. Slope, midpoint, y-intercept equation. By now, it's kind of like baking a cake. You just throw the ingredients together, and there you go. The question number 5 was a little bit different because it gave us 3 points, but don't panic because it tells us exactly what you want to find. It says of side BC. So am I concerned about point A? Not really. I don't really care about that. All I'm looking for is side BC, which means here's my x1, y1, here's my x2, y2. Same exact method, slope, midpoint, y-intercept equation. In this case, we got a y-intercept of 2.5, which is totally fine. Decimals are people too, so don't worry if you get a decimal in your answer. It is likely that you just have a question that needs a decimal. In question number 6, it's asking for perpendicular bisector. NRS and midpoint by now should be second nature. The line segment has these endpoints. One thing that you should notice is that this x value and this x value are the same, so that's going to do something a little weird to the perpendicular bisector. Finding the slope is 6 divided by 0, and when I do the negative reciprocal, 6 divided by 0 turns into 0 divided by 6. That does give me 0. This slope here, this 6 divided by 0, if I actually mathed that out, if I did 6 divided by 0 in the calculator, I would get undefined. Undefined means that you can't divide by 0, but I'm able to flip it over and get 0 divided by 6, which is 0. Doesn't matter whether it's positive or negative because 0 is neither positive nor negative. Midpoint y-intercept equation, no big deal. And then I simplified 0 times x is equal to 0, and then I don't need that term, so I just say y is equal to 2. For question 7, it asks us to do the exact same thing with a distance in the middle. Please remember the distance formula. We will not be giving this formula to you, so you must memorize this. This is a hint. So you can see the distance formula solution here. You've done this before. It should not be a big surprise. Moving on to lesson 6 problem set. This was about constructions. Pause the video, try this out, and see if you get it right. For question number 1, it asks us to make a line that's parallel to AB and intersects point R. First, I make a perpendicular line through point R, and then I make another perpendicular line. That means this angle is 90 and this angle is 90, which means that these two lines must be parallel to each other. For this question, it was much simpler. All I needed to do was make a line segment that was perpendicular to the given line segment. No big deal. For question number 3, it was a little wordy, but all we needed to do is read the set of points equidistant from the endpoints. That automatically means we're looking at a perpendicular line. For question 4 was an altitude. You did need to look up altitude. The definition was very easy to find. All you need to do is search altitude of a triangle. The rest of this problem set was pretty straightforward because all it was constructions of perpendicular bisectors and constructions of altitudes. All right, this was the video on Unit 3, the lessons 4 through 6. hopefully you are ready for this test that's coming up soon. Good luck studying.